stream consists of 10,000 tons per batch flow rate of PET was fed into centrifugal pump. The temperature and pressure was set at atmospheric temperature and atmospheric pressure. The intrinsic viscosity of PET is 0.84. Therefore, we need a pump to pump fluid that have a high viscosity. A centrifugal pump converts input power to kinetic energy by accelerating liquid in ampulla. The pressure change in the pump was set at 13.7 bar. So the temperature and the pressure were increased at the outlet stream. A specific amount of charged methanol was charged into the mixer and purged with argon. After that, the S103 was fed into pump to accelerate the fluid. S012 and S014 were fed into the mixer, then produced S105. Then the S105 was placed in the electric furnace. It took 240 minutes to reach the desired temperature, which is 575 Kelvin.
In order to produce the products of EG and DMT, a reactor will be needed to carry out the reaction process. In our case, we use vessel procedure, which is a batch reactor to carry out the reaction. First, operations are added in a sequence of transfer in, react, purge, and transfer out. So now we fill in the details required for each operation. For transfer in, S106 is selected as stream and the mass flow rate is set at 600 kg per hour. For react operation, after setting the desired exit final temperature, we proceed on by adding the reaction where methanol is reacted with PET to produce DMT and ethylene glycol, and the extent is set at 90%. For purge operation, argon was selected to purge as an inert. For transfer out operation, S108 is selected as the stream, and the process is then checked whether it is successful or not.
The reaction process, the bottom stream S108 was depressurized to stable pressure for the separation process of each component. The stream 109 consists of DMT, EG, and PET was fed to the distillation column. The light key of the distillation column is methanol and the heavy key is DMT. There are 99.99% of methanol was separated as the overhead stream. And the overhead stream is undergo a cooling process from 90 degrees Celsius to 10 degrees Celsius. And the bottom stream is undergo a heating process from 100 degrees Celsius to 150 degrees Celsius. Then the gate valve is used to control the flow rate of the stream. Then the stream 114 consists of DMT, EG, and PET was fed to the distillation column. The light key of this distillation column is EG and the heavy key is DMT. Then one of the desired product, EG was separated as overhead stream and is undergo a cooling process to condense from vapor state to liquid state. Then the bottom stream was undergo a heating process from 100 degrees Celsius to 150 degrees Celsius. Then the remaining component flow out through the cooler was used to condense the vapor stream to liquid form, and the heater was used to heat the stream in order to maintain the efficiency in the next separation process.
The component of DMT, e.g. methanol and PET, will flow into the third distillation column. We set DMT as light key, while PET as heavy key. We also set the DMT to 99.99%. So the distillate stream will come up with DMT and PET. Then they will undergo the cooling, which acts as a condenser. After that, it will produce out the DMT and PET. For the bottom part, the product will come out with DMT, e.g. methanol and PET. Since there is no flow rate for DMT, e.g. and methanol, so the important component for bottom will be PET, which is the unreacted product. Then PET will undergo the heating, which acts as a reboiler. Then PET is then proceed to the recycle stream and go back to the mixing and start over again.
Heat exchanging is used instead of electric heating and heating unit. At P3, S106 acts as the cold water and the S105 acts as the hot water, which is at 350 degrees Celsius. And the desired product is 299.85 degrees Celsius. So this means that we can use heat exchanging in this process. Try and error method is applied to S105 in order to get the desired product. At P4, S106 acts as the cold water, which is at 100 degrees Celsius, and S111 acts as the hot water, which is at 308.89 degrees Celsius. And the desired product is 150 degrees Celsius. At P9, the cold water is at 100 degrees Celsius and hot water is at 294.16 degrees Celsius. The desired product is 200 degrees Celsius. At P13, S112 acts as the cold water, which is at 100 degrees Celsius, and S125 acts as the hot water, which is at 265.55 degrees Celsius. The desired temperature for P13 is 150 degrees Celsius. So as a conclusion, heat exchanging is used instead of electric heating and electric units, and the heat exchanging is linked to each other. This can reduce the outlet stream and eventually reduce the plant cost.